So dear students, in this video we are going to discuss temperature dependence of resistivity of materials. So how resistivity depends upon the temperature for the materials, we are going to discuss in this chapter. Okay, so for instance, if rho 0 is the resistivity of material at some lower temperature T0. If rho 0 is the resistivity of material at some lower temperature T0, and if temperature increases, if the temperature increases to T, then our new resistivity becomes rho T. Okay, so as temperature changes from T0 to T, definitely T is greater than T0, so temperature is increasing. Our resistivity changes to rho T, so it may increase or decrease. We are going to find out with this equation. So if temperature increases, what happens to resistivity? So it is given by the equation rho T is equals to rho 0 into 1 plus alpha T minus T0. Okay, so definitely if you see closely, if alpha, okay, see very carefully what is happening here. Firstly, if you see closely, this equation looks like rho T is equals to rho 0 into 1 is rho 0 plus rho 0 into alpha T minus T0 will be this much. So this equation looks like to similar, it looks like to mx plus c, okay, which is the equation for a straight line where c is rho 0, m is rho 0 into alpha, and x is T minus T0. Change in temperature is your x, rho 0 alpha is your m, and c is rho 0. So this is the equation for a straight line. If we plot y with x here, it gives us straight line like this, whose slope will be m. So y is equals to mx plus c. C is the intercept. Intercept means at which point on the y-axis this straight line cuts the y-axis. That is value of c. Here c is 0. Here c is 0 because this straight line is cutting the y-axis at origin. That's why c is 0. So it is y is equals to mx plus 0 or y is equals to mx plus c. In similar manner, this equation, rho T is equals to rho 0 plus rho 0 alpha T minus T0. This is m, this is x, this is c, and this is y. Y is equals to mx plus c. So similarly, if we plot the equation, y means rho T with T minus T0, which is x, we should get a straight line. Okay, so before that I want to focus on the first equation. Rho T is equals to rho 0 1 plus alpha. Okay, you can go to the second equation, also works better here. Rho T is equals to rho 0 plus rho 0 alpha T minus T0. So if you see closely this equation, T minus T0 is always positive because I said earlier temperature increases from T0 to T. That means T is greater than T0. So T minus T0 is positive because T is greater than T0. So T minus T0 is positive. Resistivity is always positive. This resistivity is also always positive. That means positive plus. Now if this alpha is positive, then this rho T will be rho 0 plus some positive quantity. That means my rho T will be greater than rho 0. Okay, if alpha is positive, this rho T will be greater than rho 0. That means with increase in temperature, rho T also increases. Okay, with increase in temperature, rho T becomes greater than rho 0 if alpha is positive. Now if alpha is negative, rho T will be lesser than rho 0. That means in that case, resistivity decreases with temperature, because if alpha is negative, rho T will be rho 0 minus some quantity. That means it will be lesser than rho 0. Okay, so this alpha, which gives us whether resistivity increases or decreases with temperature, it is known as coefficient of it is temperature coefficient of resistivity. Something like this. See, in the book the name is given properly. I have a doubt with the name, so you can refer the book for the proper name. Now I want to give you a homework here. So homework will be there is a table. Okay, there is a table given in the book. So you need to tell me. You need to tell me which substances, what type of substances. Okay, not which. What type of substances have positive alpha, which is temperature coefficient of resistivity, and what type of substances have negative alpha. So these two things, and the third thing is what you conclude from these 2 points, your conclusion, and what you conclude from this 2 points. So there is a table given in the book. You need to refer to that table and tell me what type of substances are positive alpha and negative alpha, and what will be your conclusion after knowing such substances. Okay, so again I want to go to this equation. Rho T is equals to rho 0 plus rho 0 alpha T minus T0. So I have already told you this equation looks like this. So when you plot a graph between y and x, so here my y is rho T, and x is T minus T0, you should get a straight line. Okay, you should get a straight line, and you'll get a straight line for a medium range in temperature. Okay, it is if the temperature is greater than 0 degrees Celsius, if the temperature is this T minus T0, the T minus T0 is greater than 0 degrees Celsius, then you'll get this kind of straight line. But sometimes what will happen is if this T minus T0 is much lesser than 0 degree Celsius, then you won't get a straight line. Your equation varies. Okay, it will not obey my this y is equals to mx plus c for temperature difference much lesser than 0 degree Celsius. These two things you have to remember. For normal range in temperature, it obeys our y is equals to mx plus c graph, but at very low temperature it do not obey our y is equals to mx plus c. Now this is for metals. Okay, this is for metals, but for semiconductors the thing will be opposite. Why the things will be opposite? Now what will happen for semiconductors is, with temperature, with increase in temperature, here with the increase in temperature difference my resistivity was increasing. Here also with increase in temperature difference my resistivity was increasing, though it was not in a straight line. But for semiconductor, with the increase in temperature difference, resistivity tends to decrease. It is just opposite. Okay, decreases, resistivity of semiconductor decreases with increase in temperature. It is opposite. So why so? Okay, a reason for that we are going to discuss now. Okay, so sigma, okay, conductivity we have already calculated. Conductivity of any material is given by this formula, Na square tau by m. This is our conductivity of any material. Now we know resistivity is inverse of conductivity. Resistivity is inverse of conductivity. That means resistivity will be inverse of this one. So it will be m divided by Na square tau. Okay, so this is our resistivity, m by Na square tau. Okay, now for metals, usually what happens is, when temperature increases, it increases the thermal speed. It increases the thermal speed of electrons. Okay, when temperature increases, it increases the thermal speed of the electrons. When the thermal speed of the electrons increases, then what will happen? Then there will be more frequent collision between the electrons. There will be frequent collisions. Collisions increases. Frequent collisions within electrons. Okay, this collided with this, or electrons with atoms also. The collision between electrons and atoms increases because the speed of the electrons increases with temperature. If temperature increases, thermal speed increases, and the collision between electrons and atoms increases. Now, if collision between electrons and atoms increases, then the time period between two collisions will decrease, definitely. Why? Because if there are more collisions, more frequent collisions, then the electrons tends to collide with atom more frequently. That means the time between the two collisions decreases. Okay, so your relaxation time will decrease. Okay, so when temperature increases, thermal speed of electrons increases. That increases the collisions between the electrons and atoms, and that decreases the relaxation time of the electrons. Now if you see closely to this equation, now if relaxation time decreases, okay, if this tau decreases, our resistivity increases, because tau is at denominator. So if tau decreases, our resistivity increases. That's why with the increase in temperature, our resistivity also increases for metals. So for metals, with the increase in temperature, resistivity increases. But in semiconductors, it should be with increase in temperature, resistivity should decrease. So how it is possible? Okay, so it is possible. Up to here it is same. Okay, up to here it is same. But in semiconductors, what will happen is, with increase in temperature, with increase in temperature, the number of electrons also increases. The number of electrons also increases. Okay, but in semiconductors, up to tau, okay, tau decreases. Up to tau it is same. Relaxation time decreases with the increase in temperature. Up to that it is same, but additional thing happens in semiconductor. And what is that? With the increase in temperature, the number of electrons also increases. So the number of electrons means this n. So with the rise in temperature, this n also increases. So n increases, but tau is decreasing. Tau is decreasing, isn't it? Relaxation time is decreasing, but n is increasing. But overall effect, okay, between n and tau, okay, overall effect between n and tau give us the total value decreases. The total value, okay, increases. This increase in n compensate the decrease in tau, and the total value of the denominator increases. Total value of the denominator increases. So if the total value of the denominator increases, my rho decreases. That's why when temperature increases, resistivity of semiconductor decreases. So this is the reason why in semiconductors, with rise in temperature, resistivity decreases. In metal, with rise in temperature, with rise in temperature, resistivity either increase in straight line or increase in curve. So this is the reason. Here temperature increases, resistivity also increases. Here temperature in semiconductor, temperature increases, but resistivity decreases. This is the reason. So this was it for today. Thank you.